Hello, math people. We are looking now at part two of our slope refresher. Let me get this out of the way. Um, and let's remind ourselves of where we left off. This was one of the last slides in the previous video. And remember, I showed you y equals mx plus b. And I just said this is interesting. It's a line equation. And I gave you the equation for the line that we kept looking at, but I didn't explain how we got there. So let's go into that. All right, so here's that y equals mx plus b formula again for the line. And remember, we had points 1, 1 and 6, 3, and we computed the slope as 2 over 5. And remember that the way we did that was we used the slope formula, and we just did the subtractions, y over x, and you end up with 2 over 5. So let's take a look at how you actually get the line equation from that information. First, you plug in your slope, y equals 2/5 x plus b, and then you just use one of the point values that you know. We can use either 1, 1, or we can use 6, 3. Let's do both of them. 1, 1 is very easy because the math is so simple with the value of 1 for both x and y. So we plug in y as 1 and x as 1. 1 equals 2/5 of 1 plus b. We isolate b. 1 minus 2/5 on the other side, so b then becomes 3/5, and the formula becomes y equals 2/5 x plus 3/5. And then if we use 6, 3, the math is slightly different, but we end up in the same place. This is the y value plugged in, this is the x value plugged in, and we end up with 3 minus 12/5, because that's what 6 times 2/5 is, equals b. And then we express 3 as 15/5. We do the subtraction. We end up with 3/5 equals b. And guess what? Our equation is y equals 2/5 x plus 3/5. Thank goodness it's the same as what we already knew. Okay, let's go forward here. So this y equals mx plus b is what's called the slope-intercept form, and it's very useful. You're going to run into it a lot when you work on slope. The m value, as I've said, is the slope. And this b value is interesting. It is the y-intercept. Remember, the y-intercept is the value of y where the line in question crosses the y-axis. If you can't remember which is the y-axis, think y to the sky. Up and down is y to the sky. Excuse me. You can also think of the y-intercept as it's the value that y takes on when x equals 0, because after all, where the y-axis goes, that's where x equals 0. That's where you find it at the origin. Okay, so let's take a quick look at a cool tool that lets us see this relationship very nicely, how the y-intercept works. So what we have here is the equation that we've been using, but I have it set up slightly differently. Y equals 2/5 x, and then I left b as a variable here. But then here I set b as 3/5. So this is just the equivalent of having y equals 2/5 x plus 3/5 at the moment with b set to 3/5. And the reason I did it like this is because this tool lets me manipulate b and show you how it changes the line. So here's our y-intercept right here, okay, where it crosses the y-axis. That's 3/5, 0.6. And just because we're going to get to it in a moment, I'm going to also point out that you have an x-intercept here, right? That's where the line crosses the x-axis, and that's -1.5 or -3/2. All right, remember that. We're going to get to that in a second. But the point right now is to see what the effect is of changing the y-intercept. So let's just do that. So as I manipulate b and I raise it, the line goes higher, but as you can see, the slope remains 2/5 as we expect it to. And then I can do the same thing going the other direction. All right, so really what you have here, by changing the y-intercept, you get a series of parallel lines. All have the same slope, and the position they take is governed by the y-intercept value. Okay, so back to our algebra here. All right, so as I said, the x-intercept is where you cross the x-axis, And you can think of that as the value that x takes on when y equals 0. So how do we find it? It's very easy. We just set y equal to 0, and then we do the math. So this is the general case, y equals mx plus b, set y to 0, 0 equals mx plus b, and then isolate b, I try to isolate x by moving b over here and then getting rid of the coefficient x equals minus b over m. Then for our particular example, with this formula, y equals 2/6 x plus 3/5, again, set y equal to 0 and then see what happens to x. So if you go through the math, you try to isolate x, so you get to add minus 3/5 to both sides. That ends up over here, and then get rid of this coefficient by multiplying by 5/2, which is what I've done here, and you end up with minus 3/2 equals x, and that is the x-intercept. Okay, to recap, we know how to do the slope. We use the slope formula. We know how to do this particular version of a line equation, y equals mx plus b, the slope-intercept form. And we know how to compute the y-intercept because it's just b. That's easy if we happen to have the line in this format. And we know how to get the x-intercept, just substitute with y equals 0. Okay, so let's go forward. Another line equation form you have to know is point-slope form. And this is how it's written out officially, let's say. But the way it's usually described is, think of it as y minus the y you know, which is this y1. That's a particular instance of y. That's why you have the subscript, whereas this is the general case. This is the variable. So y minus the y you know equals the slope m times x minus the x you know. All right, again, this is the general x, the variable x, and this is a particular instance, so it actually at any moment in time has a specific value. And where this is commonly used is you're given the slope and you're given just one point, and this formula gives you a way to express the corresponding line equation. So using our example, we have the slope of 2/5. I'm going to just use the point 1, 1. Remember, we had 1, 1, and 6, 3. So let's use 1, 1. It's going to be very easy because 1 and 1 are easy to work with. So here it is, point-slope form. We're just going to do it right out. Y minus the y we know, the y we know is 1, equals the slope 2/5 times x minus the x we know, and in this case, the x we know is also 1. Right? So that's it. We just did it. It's just basically plug it in. And then just so you can see that we're really talking about the same thing here, you can use just a couple of steps to go from the point-slope form over to the slope-intercept form. All you have to do is multiply this out, so it's 2/5 x minus 2/5, and then get rid of the minus 1, so you have y isolated by adding 1 to both sides, and that turns into y equals 2/5 x plus 3/5, which we have gotten very used to. We've seen it so many times now. Okay, there's a third line equation form you need to know about. It's called standard form, and it looks like this: ax plus by plus c equals 0. And I'm going to go through the transformation between this and a format that we're much more used to, the point-slope form, the y-intercept form. You could also go to the point-slope form if you wanted to. So it's just doing the algebra. I try to get y by itself. And so the first thing I do is I put the a term and the c term on the other side, so we get the minus c and the minus ax on the other side and by on the left. Then I want to get rid of this coefficient on y, so I multiply both sides by 1 over b, and I end up with y equals minus c minus ax over b. I multiply that out, and you end up with this, and this should look very familiar. Y equals minus a, this should be a line here, sorry, minus a over b times x minus c over b, and that is the same format as y equals mx plus b, where this minus a over b is now the m term, and the minus c over b is the, I should say the small b term, equivalent to the small d term. So we can just do the substitution and get our line equation out of that. So we know that minus a over b equals m, and we know that m in our particular case is 2 over 5. So that means that minus a is 2, and that makes a minus 2, and b is 5, all right? And then the other term lets us figure out about c. So minus c over b is the small b term, and we have that at 3/5 in our example, 3 over 5. So that means that minus c equals 3, and then c is minus 3. So this is the standard form that we're trying to move towards. So we just plug it in. We plug in minus 2 for a, minus 2x, and then we plug in 5 for b, plus 5y, and then we plug in minus 3 for c, and then here's our equation. And that is just another way of saying the same thing that we already said with the slope-intercept form, y equals 2/5 x plus 3/5. Okay, the last thing that we need to take a look at is, remember we talked about parallel and perpendicular lines in the first video, and you're surely going to have questions that look something like this. You're given a couple of lines, maybe you're just given 2 points for one line, 2 points for the other, and then the question you're going to have is, are these lines parallel, perpendicular, or neither? So I'm going to use for line 1, I'm going to use the line we're already familiar with, save us a little time. We already know the slope is 2/5. We computed that previously. And here are the point values that we already know about. So now we have line 2, and I'm saying that's defined by minus 4, minus 1, and minus 6, 4. And we're going to want to get the slope of the second line. And based on how that looks relative to the slope of the first line, we're going to be able to decide whether these things are parallel or perpendicular. Remember, if the slope is the same, then the lines are parallel, and if the slopes happen to be negative reciprocals, which you can describe this way, if one is m and then the other one is minus 1 over m, those are negative reciprocals, then the lines are perpendicular. All right, so let's just do it. This is our y2 here, is the 4, and we subtract the y1 of minus 1, so it's 4 minus 1, which is equal to 4 plus 1, so that's 5 for the y term. And then the x term is, this is our x2 minus 6, minus 4 is our x1 term, so that equals minus 6 plus 4, and that resolves to minus 2. So our slope then becomes 5 over minus 2, which is the same as minus 5/2. And this is the slope we started with for the first line, and this is the slope for the second line, and those are in fact negative reciprocals. You're just flipping this over, 5 over 2, and you're making it negative. And so these two lines here, line 1 and line 2, are indeed perpendicular. Okay, I will talk to you in the next video.